It looked like a mirror lying at the bottom of the sea, flat, still, and glinting faintly in the submersible's headlights. But it wasn't glass, and it wasn't sand or rock either. It was water, a lake inside the ocean, encircled by its own shoreline, its waves rolling in eerie slow motion, as if time itself moved differently down here. The team was already deep beneath the Red Sea, miles below the surface. Yet what they saw in front of them defied every rule we thought we understood about Earth's oceans. They weren't looking at an illusion or a strange reflection. They were staring at something that, by all scientific logic, shouldn't exist at all. A body of water trapped inside another. A place so hostile to life that even the most resilient sea creatures drop dead the moment they touch it. And yet, something does live here. Something ancient. Something alien. What exactly did they find? And how is it even possible? If these lakes hadn't been discovered, we might still believe that sunlight is the only thing that makes life possible. That life on Earth, and maybe in the universe, can only bloom under blue skies and golden heat. But these underwater anomalies reveal something far more profound. They show that life can survive, even thrive, in absolute darkness, without a single ray of sun, in toxic waters filled with salt and methane. Without them, we'd have missed the clue that life may have started not in a shallow pond, but in a deep abyss. And we'd have ignored the chilling possibility that similar lakes could be hiding in other worlds, frozen beneath alien oceans, waiting to be found. The deeper we go, the more it becomes clear. The rules of life aren't just being rewritten. They're being erased and replaced by something stranger. Take a breath. Let that idea settle for a moment. If you find wonder in the hidden corners of our world and the quiet mysteries that lie beneath the surface, consider subscribing. There's so much more to explore, and I'd love to have you with me on the journey. In 2020, a deep-sea expedition in the Red Sea sent a submersible thousands of meters beneath the surface, into the unlit silence of the abyss. For hours, it scanned the ocean floor, a barren, desolate landscape with nothing but sand, stone, and shadow. The crew had almost given up, resigned to the idea that this mission, like many others, would return empty-handed. But just before they began to ascend, the submersible's lights caught something strange, something that didn't belong. In the distance, stretched across the seabed, was a dark, smooth shape, as if a giant mirror had been embedded in the ocean floor. This wasn't coral or a rock formation. This was something else. Something that would change how we think about life on Earth. The closer they drifted, the stranger it became. The ocean around them, already thick with gloom, seemed to grow even darker near the anomaly. The submersible's lights reflected off the surface in a way that didn't make sense. Not like a rough seabed or uneven rock, but like polished obsidian. It was unnaturally smooth, rippling faintly as if touched by an invisible breeze. In this pitch-black world, it shimmered like a phantom, a perfect, glassy layer that seemed to hover above the sand. Then they saw the impossible, gentle waves, lapping slowly against the edges. The surface wasn't solid. It was liquid, a lake inside the ocean, not a dream, not an illusion, but something undeniably real and impossibly wrong. In that moment, the crew didn't celebrate. They didn't shout. There was no music of discovery, no triumphant voices over the radio. Just silence, the kind that sinks deep into your bones. They were staring at something no human was ever meant to find. The crushing pressure of the deep was nothing compared to the weight of what they were looking at. A place where normal rules didn't apply. The stillness of the lake, the slowness of its waves, the sheer impossibility of its existence. It all felt like being in a dream that had taken a dark turn. Somewhere in the back of their minds, each of them must have felt it. This wasn't just a scientific discovery. It was a glimpse into another world, hidden beneath our own. And whatever lay beneath that surface didn't want to be found. Long before this modern crew gazed into the abyss and saw the reflection of something impossible, there had been whispers, faint traces in forgotten papers, long buried in scientific archives. In 1964, an English oceanographer named Henry Chernock published a quiet, almost unnoticed article in a marine journal. It described what he called anomalous bottom water deep in the Red Sea. At the time, no one paid it much attention. But decades later, researchers would realize that Henry had unknowingly stumbled upon the same impossible phenomenon. Without a submersible or modern sensors, he had detected something dense, unnaturally warm, and far saltier than the surrounding ocean. He didn't know what it was, only that it shouldn't have been there. That lonely data point, recorded by a humble scientist over half a century ago, was the first breadcrumb in a trail that would eventually lead to the lake at the bottom of the sea. What they had found was more than a curiosity. It was a direct contradiction to everything marine science thought it understood. A lake inside the ocean, not a poetic description, but a literal reality. It had its own surface tension, its own shoreline, its own waves. And yet, it was made entirely of water. Not fresh water, not even seawater, but something far denser, heavier, and more dangerous. A hypersaline brine, so thick it formed a self-contained layer at the bottom of the sea, unable to mix with the ocean above it. And inside it, things lived. Not ordinary fish or crustaceans, but something far stranger. This wasn't just a place. It was a sealed world, one that had existed for millions of years in complete darkness. Untouched, unknown, and waiting. These mysterious underwater lakes are known as brine pools, pockets of extremely salty water trapped on the seafloor. Unlike the ocean around them, brine pools are so saturated with salt that they become far denser, forming a distinct boundary between themselves and the water above. It's this density that gives them their eerie, lake-like appearance. The separation is so sharp that a submersible can literally bounce off the surface of a brine pool like it's hit a watery trampoline. To the naked eye, it's like staring at another world, submerged within our own. A lake resting silently at the bottom of an already unfathomable ocean. But brine pools aren't just bizarre to look at. They're lethal. Their dense waters lack oxygen, are loaded with toxic gases like methane and hydrogen sulfide, and can kill most marine creatures within seconds of contact. At first glance, it seems impossible that one body of water could simply sit inside another without mixing. But the secret lies in the way salt and heat move through water, a process called double diffusive convection. Salt spreads slowly, heat spreads quickly. In the case of brine pools, the bottom layer, the brine, is both warmer and far saltier than the seawater above it. The heat rises upward more easily than the salt, creating a strange phenomenon. The layer directly above the brine gets warmer, causing it to rise and move away. Meanwhile, the water just under the brine's surface cools and sinks deeper. This stabilizes the two layers, preventing them from blending and creating a sharp, almost invisible surface, like oil sitting on water, but far more stable. This is what forms that mirror-like boundary. It's not just water sitting in water. It's two rival forces in perfect balance, each holding the other in place. To understand where all that salt comes from and why it gathers in these bizarre, deadly lakes, we have to go back hundreds of millions of years. Long before modern oceans formed, the basins that now hold the Red Sea, the Gulf of Mexico, and the Mediterranean Sea were once cut off from the open ocean. With no new water flowing in, these isolated basins slowly evaporated under ancient suns, leaving behind vast beds of pure salt, thick, deep, and buried beneath layers of sediment. Over time, As more rock and mud piled on top, the pressure compressed the salt until it started to behave in strange ways. It didn't stay still. It began to flow and shift like thick clay, rising in bulbous columns known as diapirs. As these columns pushed upward, they cracked the seafloor and allowed tiny streams of seawater to seep in. That water mixed with the buried salt, creating ultra-concentrated brine, which was eventually forced up to the ocean floor, pooling into the strange lakes we now see today. This process is called salt tectonics, and it's the hidden engine beneath every brine pool on Earth. You might wonder, if this is just water, even salt-heavy water, why doesn't it simply blend into the ocean over time? After all, pour salty water into a glass of fresh water, and it mixes almost instantly. But brine pools aren't that simple. Their density creates a natural barrier. The water in these lakes is so heavy that it sinks into the seafloor's low points and stays trapped there, like liquid iron nestled in the ocean's cracks. And thanks to the double diffusive convection process, the warm salty brine and the cold fresher seawater don't mix. They stabilize each other. This forms a persistent boundary, often called a halocline, that marks a sharp and eerie line between life and death. The brine is also constantly being replenished from the seafloor below, just as it slowly leaks upward and dissolves into the ocean. It is simultaneously fed by new flows of concentrated salt water from deep beneath the Earth's crust. The result? A stable, sealed-off body of water, alien, ancient, and seemingly eternal. Brine pools aren't always still. Sometimes they move silently, slowly, and with a kind of haunted grace. In 2018, researchers in the Gulf of Mexico observed something no one expected: a brine waterfall. From a slope above a brine pool, thick, dark streaks of dense, salty water were seen cascading down into the lake below, like a waterfall in slow motion, flowing not through air, but through the ocean itself. These rivers of brine don't just sit in pools. They can creep across the seafloor, following ancient channels carved by salt tectonics. Over millions of years, the pressure of buried salt reshapes the ocean bed, opening new paths for brine to travel, spread, and settle. As it flows, the brine carves out new depressions, forms new pools, and sometimes merges with others, creating ever-expanding lakes of dense, toxic water. To witness one of these flows is like watching Earth bleed in slow motion, a movement that's invisible to us on land, but changes the world beneath the waves. To most life on Earth, brine pools are instant death. The moment a fish or crustacean drifts too close to the surface, its fate is sealed. These waters contain almost no oxygen, are packed with toxic methane, and are so salty they can chemically burn the cells of living organisms. There's no light, not even a faint glimmer from the sun makes it this far. And unlike the rest of the ocean, which still relies on a delicate chain of sun-fed life, this place is totally cut off. The conditions are not just extreme, they are actively hostile. Imagine trying to survive in a poisonous bath in total darkness under the crushing pressure of the sea. That's what these lakes offer. And yet, something lives here. The shorelines of these underwater lakes aren't just strange, they're haunted. Scattered across the edges of the brine pools are the preserved bodies of creatures that made one wrong move. Fish, eels, crabs, lobsters, all lying eerily intact, their bodies frozen in twisted postures, their muscles seized mid-convulsion. These aren't skeletons. There's no rot, no decay. Instead, they're mummified, embalmed by the brine itself. The salt concentration is so extreme, it dehydrates and preserves anything that falls into it, like nature's own pickling jar sealed for eternity. Some of these corpses have been sitting there for decades, untouched by scavengers or time. And the most unsettling part? They aren't scattered randomly. They tend to gather right at the edge, where the normal ocean meets the toxic brine, as if the creatures had approached cautiously, unsure of what they were sensing. And then, one step too far. It's a graveyard with no mourners. A silent warning to everything that comes near. What enters here does not return. Despite everything, the toxic chemicals, the lack of oxygen, the eternal darkness, life endures. Not just microbial specks drifting through the brine, but full-blown ecosystems, hidden in the shadows of death. Around the brine pools, scientists have discovered colonies of bright green tube worms, 100-year-old mussels, ghostly crabs, and jelly-bodied shrimp, all clustered at the very edge of the poison. This is not a random scattering of survivors. It's an organized, thriving network of life. What's truly remarkable is how deliberate it all seems. The creatures avoid the center, where the brine is thickest, but they gather in tight clusters. Along the border, like animals crowding around a watering hole in a desert. But this isn't a place of nourishment. It's a place of constant risk. And yet, these species have adapted, not just to survive here, but to depend on the very forces that kill everything else. It's a paradox, a circle of death feeding, a community of life. And it raises one impossible question. If life can flourish here, where else might it be hiding? At the center of this bizarre ecosystem is one creature that stands apart from the rest, the hagfish. Slimy, eel-shaped, and ancient beyond belief, these scavengers don't just survive near the brine pool. They enter it. While most sea creatures die within seconds of contact, hagfish swim freely through the toxic waters, hunting for the freshly paralyzed victims who've wandered too far. It's as if they're immune to the lake's deadly grip, as if they were made for it. Scientists call them living fossils, creatures whose physiology hasn't changed in hundreds of millions of years. And yet, their survival here hints at something even more mind-bending: chemosynthesis. Unlike most life on Earth, which relies on photosynthesis, turning sunlight into food, life around brine pools is powered by chemicals, particularly methane. Inside the gills of mussels and other organisms here live colonies of specialized bacteria. These bacteria don't eat food or sunlight. They consume methane and convert it into energy, fueling entire species in the process. It's like watching an alien food chain in real time, a closed loop powered by poison and darkness. A survival method so foreign, it makes the surface world feel almost primitive by comparison. What makes brine pools more than just a scientific curiosity, more than a horror story at the bottom of the sea, is what they suggest about our own beginnings. Billions of years ago, Earth was a hostile place. There was no oxygen in the atmosphere, no plants, no sunlight penetrating the deep seas. Instead, the oceans were thick with methane, heat, and salt, a chaotic stew that would seem unlivable by today's standards. And yet, it was in these conditions that life began. When scientists look at brine pools, they see a mirror, not just a physical one, but a mirror to the primordial Earth, a place where life might have first sparked. The methane-rich, anoxic waters are nearly identical to what researchers believe early oceans were like. And the creatures that survive here, using chemosynthesis, building life from poison, could be the modern day cousins of Earth's first living cells. Some even believe that this is the true warm little pond Darwin once imagined. Not on the surface, but in the depths. Not bathed in sunlight, but in darkness and salt. And if life could begin in a place like this on Earth, what's to say it couldn't happen somewhere else? For centuries, scientists believed life was impossible without sunlight. Plants turned solar energy into food through photosynthesis. Animals ate the plants, and so the chain continued. Even in the darkest depths of the ocean, it was thought that life could only survive by feeding on organic debris falling from above. The so-called marine snow that trickled down from sunlit waters. But when ecosystems like brine pools and hydrothermal vents were discovered, that idea collapsed. These were not scraps surviving on leftovers. They were full, self-sustaining webs of life, powered not by the sun, but by chemistry. Instead of photosynthesis, organisms here rely on chemosynthesis, where bacteria extract energy from methane and other chemicals leaking from the Earth's crust. Entire communities of worms, clams, crabs, and even fish live off this food source. It's proof that sunlight isn't the only fuel life can use. And if that's true, then life could be more common, more adaptable, and more alien than we ever. Imagine when Charles Darwin first speculated about the origin of life. He imagined a warm little pond, a shallow, sunlit pool rich in nutrients, struck by lightning and sparked into something alive. For decades, this poetic image shaped our understanding of how life began. But now, with discoveries like brine pools, that vision is being challenged. Because when we compare the conditions of early Earth to what we see in these underwater lakes, the similarities are almost too perfect to ignore. Billions of years ago, Earth's oceans were dark, hot, low in oxygen, and rich in methane and salts. Exactly like the chemical soup found inside brine pools today. Add the geological activity, the constant heat from beneath the crust, and the concentration of minerals, and you get something not unlike the environment where chemosynthetic life thrives now. It's not just possible that life could have begun in a brine-like setting. Many scientists now think it's likely, because in these places, nature doesn't just create the conditions for life. It creates the energy life needs to survive. If life can survive, and possibly originate, in the pitch-black, high-pressure, toxic depths of Earth's oceans, then what about the rest of the solar system? Two celestial bodies have drawn serious attention. Europa, a moon of Jupiter, and Enceladus, a moon of Saturn. Both are covered in thick ice. Both show strong evidence of liquid oceans beneath their icy crusts. And crucially, both are believed to contain salt, methane, and even signs of hydrothermal activity. In other words, the same deadly conditions we see in Earth's brine pools, the very conditions once believed uninhabitable, might be present right now, just beneath the frozen skin of these distant moons. Before we understood chemosynthesis, the lack of sunlight in these alien oceans would have been a deal-breaker. But now, these worlds are prime candidates in the search for extraterrestrial life. If even a sliver of a brine-like ecosystem exists under Europa's surface, with chemical vents, dense salty waters, and microbial colonies, it could be the best shot we have at finding life beyond Earth. And it wouldn't just change what we know about the universe. It would change what we thought we knew about ourselves. Brine pools, on Earth or anywhere else, force us to rethink the very definition of life. For generations, we imagined it as fragile, dependent on warmth, air, and light. But the life found clinging to the edges of these underwater lakes tells another story, that life is resilient, resourceful, and sometimes completely